Today, like I said, we want to talk about our water phantoms, and what are the objectives of a water phantom? Obviously, your acceptance testing, you're checking your systems versus the manufacturer's stated specs, the commissioning of the Linux, import into TPS, and checking all your energies and field sizes, your wedges, etc. Your annual QA that's recommended in those TG 142 tests, your monthly QA for the TG 51 or TRS 398, depending. And then, of course, your periodic checks of your beam quality as needed, after a PM or if there is a downtime and there's some or some linac repair, things like that. You might want to pull out the water phantom and do some checks. So that's kind of the objectives of a water phantom. Obviously, probably nothing new to you, but just kind of pointing things out. And what makes a good water phantom? Obviously, very highly accurate and repeatable positions, high quality raw measurements, and that has a lot to do with the geometries and the rigidity and the repeatability of the hardware. Um, and it's such reliable hardware that is in operation year after year. It's not something that you typically use on a daily basis, as far as the water phantoms go. So you don't want to have to go and relearn that software, and you don't want to have a long time setup and kind of relearn the whole system. So that's why we kind of built it around very easy setup and use. Because again, it might not be, it may only be used on an annual basis if you're talking the 3D, or a monthly basis if you're talking the 1D, things like that. So we really concentrated and built it around easy setup and use. And then you want that flexibility and compatibility, not only for variants of different detectors, the various different protocols, be it the AAPM or be it the IEEA, the Japanese protocols, Indian protocols, things like that, are all incorporated into our system. And along that line too, your various TPS formats. So if you're going into to Pinnacle or Eclipse or uh, you know Monaco, we have those capabilities as well. So you want to be able to have that functionality and flexibility. But as far as one thing we did, like I mentioned, we wanted to build something around very good hardware. So because the better the hardware, the better the data you're going to get out of it. So we really concentrated on our development for accurate and consistent positioning. We use a heavy gauge extruded aluminum frame that really maximizes that rigidity. It simplifies the setup and it maintains that reproducibility. The predictional accuracy and repeatability is within 0.1 millimeter per axis. We utilize redundant motors, so you won't have any cantilevering or skewing of the robot arms as it scans through the water. They kind of maintain their positions because there's multiple motors doing the job. It allows for a precise and quick 3-point leveling, very quick and easy to do. It's a manual setup, and we've just not we looked into what's existing out there as far as automatic leveling, and we've played around with some of our own internally, and there's still the tried and true 3-point leveling, and the way our system is set up, you can do it just as quick with our 3-point leveling as you can, if not quicker than some of the automated ones, because with the automated ones you need to kind of start from scratch if you don't quite get there and your runouts are not level. This you have the ability to do very minor tweaks to it as you do your leveling. And then along the accuracy kind of side of things, each individual system is tested on an industrial coordinate measurement unit to verify that accuracy and performance even before it goes out the door from standard imaging to you. We maintain those 0.1 millimeter axes per axis accuracies. So you can be assured that when you receive the system, you'll be getting those accuracies as well. As far as our water phantoms go, as I mentioned up front, we've got both our 3D water phantom, which is available with either a lift to reservoir cart combined, or just a lift cart only. If you don't want the reservoir, we've got those functionalities available to you. Our Doseview 1D Phantom has two sizes available, a larger and a smaller tank, as well as includes 3-point leveling, the ability to easily set up and maintain the memory of the position of the chamber as you go outside, disconnect the Phantom, and then reconnect it to either our Supermax or our Max 4000 electrometer or our Max 4000 Plus. So it becomes an integrated system with our software utilizing those electrometers. The new Gen 2 second generation Doseview 3D has a lower profile, more compact design for improved rigidity throughout, but also makes it Halcyon compatible for use in the Halcyon bore for doing your QA and measurements within that system. We also have a lot of time-saving features that go into our 3D water phantom. We've got a very innovative and versatile detector alignment system. You can see it comes with a number of different chamber holders down in the lower right, as well as our water surface alignment jig. And the alignment jig allows you a quick and easy visual leveling of the water of the chamber carriage to the water level, and basically gives you the ability to quickly mount a chamber and swap that out with the alignment jig and assure you that you get the chamber in the correct position. So it's a very fast and precise setup. We got, like I said, we've got the multiple detector holders included, including not only for our A28 scanning chambers, but also farmer chambers, a universal holder, and then a number of different ones for parallel plate chambers too for your electron measurements. That intuitive jig that I kind of mentioned, you can kind of see that cartoon drawing kind of showing you how the visualization works. We have an automatic fine beam center functionality in the software as well, which basically runs the chamber out to the 50% lines of the beam, and then gives you the adjustment shifts for centering that chamber very easily, very quickly. The Doseview 3D includes two of our X-ray and A28 scanning chambers. They're 0.125 cc in volume. They're a spherical collecting volume, so if you're running in plane or cross plane, you don't need to change the geometry of the chambers or the position of the chambers. You'll get good results in either direction. As I mentioned at the top regarding our chambers, it's a homogeneous Shanka C552 plastic construction for the guard, collector, and shell. So it's a very low Z material, virtually invisible to the beam, is pretty much very little beam perturbation as far as not having any high Z materials. And we've got that proven X-rated quality, and we're so assured of that quality that we offer a 5-year chamber warranty, something that no other chamber company, excuse me, in the market is doing. And then we also have a complete offering of X-rated chambers and detectors from our full range of ion chambers from the A16, which is 0.007 cc, up to our farmer chambers are 0.6 cc, A19 and A12, as well as our spherical chambers for environmental and radiation protection kind of development, going from all the way up to a 15-liter spherical. Now, kind of moving away from the hardware into the software, we in 2020 we released new updated Doseview software that integrated not only the 3D existing software, but also integrated the 1D software into there. So it's a much more powerful functionality. It's a web-based layout following that Doseview 3D software. And now it's a single software package to perform all your water phantom operations, both your 3D and your 1D. So if you're doing your depth measurements with your 1D or your profiles in depth with the 3D, it's a single software package for you. But a little more about the software. It's like I said, it's a very easy to use web-based interface, something you're very used to. Left to right, top to bottom navigation, so it's easy to navigate through. there's what we call no hidden features. Everything is kind of at your fingertips. You don't have to go digging for different functionalities and different capabilities within the software. It's all right there for you. Very intuitive menus, not only for your scan queue setup, but also for your measurements themselves, and then your post scan analysis and post scan processing. Very intuitive all the way through. So, some of the features. We have a very fast queue setup for not only your depth scans and your profile scans for all energies and modalities, be it conventional photon electron or triple F modality as well. Um, Conversion of the depth scans to dose, and easy export to not only PDD tables but also TPR tables. Full export to any number of treatment planning systems um, out there as well. So we've got a number of those, and those are all included. They're not individually charged. So if you've got a center that may be using one treatment planning system, or you have two different, if you have a variant Linac and Electa Linac, and you're using Monaco for one and Eclipse for others, you don't need to pay extra for the different treatment planning systems. Um, the 1D side, actually, they're both sides for your depth measurements. You've got a force point at Dmax. So if you set up a scan queue and a scan path that might not necessarily have a dwell point at the projected Dmax, we can force a measurement there, and then the path returns back to your initial selected path and points for measurement. And then we also, with the 1D side, we have easy 1D single point measurements as well. So if you're doing your monthly absolute measurements, then you can utilize the 1D single point measurements as well. But I'm going to kind of do a quick run through of the software now, kind of give you just kind of an overview of it. Like I said, this is not going to be an in-depth demo, but I'll be happy to do that at a kind of a personalized demo time. What's convenient for you? Just let us know what works, so we can schedule that. I'm going to jump into the software here. So basically, we have the enter the Doseview 3D side or the Doseview 1D side. I'm going to jump into the 3D side because it kind of incorporates the 1D, because obviously you're going to be doing your depth measurements for the 1D. But kind of go in there, get a little information as far as what clinics and machines you have. Basically, you can easily add centers. If you click on a center, then you can add your various machines, be it Electa or Varian, Halcyon, or whatever, what have you. So easy enough to do. Same with detectors. You can add the types of detectors you're using. Very simply, choose the add button, put in the type, who the manufacturer is, whether it's one of our X-ray chambers or another manufacturer. You can put in the model name, the type, the inner diameter for those dose conversions later on, serial number, and any comments you have too. So nice thing as well with we have the types. So we've got obviously your cylindrical chambers. We've got the parallel plate chambers as well, diodes. And then we have other detectors, and that kind of might include our scintillation detector, our W1 or W2 scintillation detector, or like a diamond detector, things like that. And then you can choose whether it's another type of detector with bias or no bias. And the nice thing about that is not only with our diodes, but also our other no bias, if you have those selected when we move into the measure component of the software, it will not allow you to turn bias on, so you don't have to worry about damaging either the front end of your electrometer or damaging the detector itself. It just will not let you apply any bias to those types of detectors. Preferences, that's where you set your time and your CSV delimiters, things like that, your date format, what have you. So that's kind of self-explanatory. But I want to jump into scan queues here and just kind of show you how easy it is to set up a scan queue. Basically, this is the add queue page. You just give it a name. So I'm going to just call it demo set. And you'll see over here things that either say complete or not set. So once those are all set, you can move on. And you'll see after I put in a name, I have that marked as complete. But I do want to maybe mark this as a MLC, not just JAWS. So I've got that functionality squared. Go to my energies. I want to do 6 and 10. Maybe with this one I have 25 MB as well, so I can add that very easily. And I'm like, oh, wait a minute, I don't have that. I can take that away just as easily as well. So I've got the different energies. Choose my field sizes. For this, I just want to do a 10 by 10 and a 20 by 20. You see those are all getting marked complete now. I can add different field sizes. I can do asymmetrical field sizes. If I've got cones, I can put in a circular and I can put in my diameter cones. So it gives you some functionality there as well. And then moving into scan types, you've got your cross plane, in plane, you've got your depth measurements, diagonals, you've got your cross plane diagonals of, sorry, your cross plane half scans and in plane half scans as well. So those can all be chosen. In this case, maybe I want to do an in plane, I want to do a depth and a cross plane. And you'll see I had a couple more things pop up here. So I can go in and I can choose my depths. Similarly, I can add different depths to it. If I want to do something at 1.5 cm, I want to do something at 10 and maybe at 20. And then my tax offsets. So in this case, I just want to do central axis measurements, but I can add my offsets here. If I want to go out to 10 cm and measure along that axis, I can easily do that. But for this one, I just want to do 0. And then finally, I have what we call our scan mode. And this is kind of where you just choose a couple different things. You can either choose step or continuous. If I want to do continuous, you'll see that my speed is now in millimeters per second as opposed to step where my individual steps are measured in millimeters. And I can do what I call zones, and I can either have a single zone where it's a single resolution all the way across, or I can pick multiple zones. And here, if I want to have a little higher resolution, say in the penumbra region, I can do that. In this case here, I'm going to do a resolution of 1 millimeter steps. But in the flat region and the tail region, I want to do 2 millimeter steps. So you can also choose your size of those zones. You can choose your overscan a specific distance or a percentage of your full width half max. You have that functionality. So there's that there for the multi. You got your depth measurements. Similarly, you have the ability to, here's that force point at Dmax I had mentioned. So if I don't have something that's going to hit a specific point at Dmax, I can force that measurement. Similarly, I can do zones here. If I want to have a little more resolution in the Dmax region, I can do that. I can choose my direction up and down, my start points, etc. So you have all that functionality there for your setup. But that's it for scan setup. So right now I'm doing that, and I've set up a total of 28 total scans. So it keeps track of that for you and lets you know what those scans are. And then you've got your scan queue setups right here. So from there, easily go to measure. Nice thing too, with our software, you have choose your water phantom. You can choose a demo 3D. You don't need to be connected to a water phantom, and that's like nice in the situation where if you don't necessarily use a water phantom, very regularly, like in the case of a 3D phantom, you can go in and before you're doing your scanning, kind of play around with it, just kind of refamiliarize yourself with the software and move forward. So I can go ahead and connect that. I can initialize it from here, or you can initialize it in the bunker from the pendant. You can choose your specific detectors, your electrometer, set your bias accordingly. You can apply that to the field or the reference, and you can zero from here as well. So I want to do just set those accordingly. Here's my position. I can move my chamber to a specific spot. I can set my origin here. I can go to an origin if I set the origin within the inside the bunker with the pendant. Here's that locate beam center. That'll give you the ability to kind of run that chamber out to the 4 extremities at the 50% lines and give you any kind of shifts to get that centered. And then the phantom orientation, this basically tells you where the junction box is, or the motion control unit, and how that's situated under the gantry. So if you come in there this way, or you're coming from the side, what have you. So and again, similarly, you have the if you're seeing standard imaging blue here as opposed to not ready or gray, you're good to go. So we can go ahead to the queue. I can load a queue, and maybe I just want to let's see, just maybe do a triple F test queue. See what we got there. And you have a number of different detectors here, or different, I'm sorry, different scan. The different scan sets are separated by color. So at this point here, you've got one scan set here. You need to change something from 6MV. Here you need to change it to triple F. So it just kind of lets you know, and it will pause and let you know when you'll have the need to either change a field size or change an energy, depending on what your scan view calls. So again, here I can zero my electrometer. I can normalize from here. So if I go to my normalization depth, I can go to that position, I can normalize and close that, and then I can start my scan. And you'll see here as it's scanning, this is just a demo scan, so it won't actually be showing you real data, but it's just showing you kind of a simulated data. But it gives you shows you what scan you're on in the scan queue here. You can see the first one is marked by green, and then the progress of that particular scan. So you'll get the data as it runs through, and you'll get that scan across. You've got the ability then to select your different protocols, either APM or triple F, your variant specific for your metrics or your Electa IC or USA measurements. So that's all part of the capabilities there as well. And so while that's scanning, I'm going to jump into my analyze side, just kind of show you some of the tools within the analyzation component. There's a couple different triple F scans I like to show. So these two here, they're the same scan, and this kind of, well, I'll be able to show you kind of what's coming in our next version, probably within the next month or two. We're out in beta testing right now, but basically, I've got a couple of triple F detector, or I'm sorry, a couple of triple F scans here. I always have the ability to kind of take a look and see if there are any filters attached. These are both normalized at center. I can show my raw data. So here's the raw data in the dotted lines, and here is the normalized data there. So I can turn that on and off accordingly. You can always have access to the raw data if you apply your filters, be it a couple different smoothing filters, either Gaussian or Boxcar, a few different the ability to point edit different measurement points, normalized to a specific value. You normalize the center. You can center the scans. You can do an average symmetric. You can mirror minus to plus. You can mirror positive to negative. You can flip the scans. You can shift the scans. So there's a lot of different things you can do within the scans. The nice thing is that it always keeps track and always maintains your raw data. So if for some reason, we used to have a physicist here who would say, 2 o'clock in the morning scanning, I would maybe do a shift, but then I'd come at 9 o'clock in the morning when I've gotten some sleep and I realized that necessarily didn't need to do that shift. So you can always go back to your raw data. You can remove the last filter. You can clear all those filters. So you have that functionality as well. Down here, you've got the different metrics showing you very easily here, with our triple F, because it's a triple F beam. You've got your center location, you've got your edge, your penumbra, the CAC percentage, the max percentage, minimum percentage, your asymmetry, your 20%, 50%, 80% points. So there's your metrics for that. Kind of also mentioned that the new version is coming out very shortly. One thing you can do, we've added some increased capabilities with our scan comparisons. So you can actually set a number of scans as what we call a reference scan, and then you can compare a more recent scan back to that reference scan. So in this case here, we have scan number 460, which is the green one. This is our reference scan as noted by the asterisk here 455 is a similar scan being compared to that 460. So that's being compared. You'll see here you have a gamma analysis map out here. And then you also have numerical comparison here. So your full width half max, 30.01 with the scan itself, but the reference is 30.02. So kind of pretty close in line, across the board as far as your measurements go. But you also have the ability to visualize that gamma also. But full, like I mentioned, export to any number of treatment planning systems. Um, you can see here Eclipse, Monaco, Aqua, Pinnacle, Research. We're also adding with the new version coming out, CyberKnife. You can export it in a Doseview format. So if you have the Doseview software on another computer that you want to maybe do some analyzing, you can export to that. Export it in a CSV file. You can export to PDD tables or TPR tables. So that functionality is all there as far as the exporting goes. You can import scans. Like I said, if you export from one computer and want to import another, you can do that. Report in CSV functionality as well. So that's kind of a quick overview of the software. Like I said, it wasn't an in-depth or meant to be an in-depth demo, just kind of just an overview. But a little bit of a summary here. Like I said, the software, easy left to right, top to bottom navigation, quick queue setup for 1D scanning and 3D scanning. And something I didn't touch on, but there's also very easy copy and editing functions of the scan queue. So if I set a scan queue up for 6 MV and I want to do that same exact queue, but for 10 MV, you can easily copy that 6 MV and edit it to a 10 MV with just click of 2 buttons. It's very, very quick and easy. Like I said, no hidden features. Everything's kind of at your fingertips. The ability to do step or continuous scanning with the multiple zone resolutions as well. Full export to your PDD tables and your TPR tables. You got that import functionality from legacy scan data. I didn't mention that, but if you've got an older IBA or PTW water phantom and you've got scan data, you can import those scans into Doseview for comparison of that data to data taken with the Doseview. And then very easy, very straightforward post-scan processing and metrics. And the nice thing, a lot of our users find that the raw data we get out because of the pains we've taken not only for our software but also for the hardware accuracy. There's very little post-scan processing that's necessary, so it's pretty quick and very straightforward. So something I mentioned as well, coming soon in our version 3.1, probably in the next month or so. It's out in beta at a few sites being tested. Direct comparison back to user selected set of reference scans, including that gamma analysis and metric comparison, and then also the TPS and TPR table export to CyberKnife.